I did my project based on a finger game I played as a child. In this game, each person would start with one finger on each of their hands. One player would start by tapping one of his hands to the other person's hands. When this is done, that player would add that many fingers to their hand. An example is, if I used one finger to hit somebody with one finger, they would now have two fingers on that hand. Each player keeps doing this back and forth until one player has won the game. In order to win the game, you have to get the other player to have 5 on each of his hands, because once you hit 5 in your hand, that hand is gone. After figuring out what phenomenon I should use, I decided I should start making rules so that way I could start categorizing my data. The first rule I did was player 1 always goes first. I did this so that way patterns could be found, and so that way it was easier to see if anything specific happened with who won. Next, I made it so you always start with one finger on each hand, no matter how many hands you use or what you use as the mod, just for convenience. Next, I was looking at the trivial cases, like what happens if you have mod 0 or 1, but I didn't really want those affecting my data and skewing it, so I took them out of the equation at the beginning. The last rule I put in place was the use of remainders, which would be like mod 5, which is the normal. If you went above 5 fingers, you would go down to 1, so if I hit one hand with 3 using 3, it would go to 6, but 6 mod 5 is 1, so that finger would go down to 1. In this example, somebody that has 4 on one of their hands is going to hit the person with 3 on their hand, and that's going to go up to 7. Since 7 mod 5 equals 2, that hand would now go down to 2 instead of just disappearing like in a normal game, where if you went above 5, the hand just disappears. Once I had declared my rules and what the game is, I started looking at who would win in each game, where there's no choices, which would be one hand versus one hand. And for this I looked at who would win starting with one finger all the way to 5, or N in some cases, because eventually it would repeat depending on what the mod is. So what I found while looking at most of the graphs is, in a specific mod, usually one player dominated, or it alternated depending on how many fingers you started with. With this, when one player dominated, I would always see which player and what's the percentage of their chance of winning. I found out that in most scenarios, player 2 is usually the one who won. Once I figured out who would always win if there was one hand on each side, no matter how many fingers you started with and depending on what the mod is, I started looking at what happens if there's 2 hands on each side. In order to figure this out, I started taking extensive data. To get all this data, I started looking at every single possibility that the game could turn out and saw if there was any patterns in which one person can force the other person to lose. After I collected data on who would win in a 2-hand thing between mod 2 and mod 5, I started looking at what would happen if we had always mod 3, and what happened if we changed the number of hands, starting with 2 going up to 4, or mod 3 going up from 2 to N. This is the data I got on who would win, assuming player 1 always goes first, in 2 hands each. As you can see, it alternates who wins each game, and on the bottom 3 it says can always win. I'm putting this can in because there's a chance that the player doesn't always win, and this is if they choose the wrong path. But assuming they choose the right path or play a perfect game, then they can always win. This alternating pattern is due to the mod and how one player gets one hand of the other player out first. When this happens, that player has a great advantage. Next, instead of keeping the number of hands constant and changing the mod, I decided to keep the mod constant and change however many hands you start with. For this, I found very different results. What I found was, in a mod 2, no matter how many hands each player starts with, assuming they start with the same amount of hands, the first player, whoever goes first, would always win. Compared to with mod 3, if they start with 1 or 2 hands, then player 2 would always win. But if I started with more than 2 hands, player 1 would always win. Next I looked at mod 4, and saw that with any odd amount of hands, player 2 would always win, and with an even amount of hands, player 1 would always win, which looks similar to what would happen if there was always 2 hands and we changed the mod. I believe these results may be due to who gets the first hand from the other player out, which could contribute to who would win a lot easier, because once you have one more hand in the opponent, you have a great advantage. If it ends up that the player who wins is a player who could take out one of the opponent's hands first, I could go back to my original chart, which shows who would win in a 1-hand versus 1-hand, and always find who would win, no matter what amount of hands each player has, depending on the mod. What I've learned from this project is, Although some paths may look like they have results in the end, some may not. Like, I started with looking at which player would win and how many turns it would take, and seeing if there was a pattern with that. Sadly, I got minimal to no results, and so I also just tried with remainders, and so there was a lot more possibilities. I also found out that with my project, it wasn't all computational data, it was pattern finding, and the biggest pattern I found was the player that got the first hand out on the opponent would usually win, and this helped me find many patterns throughout this project.